Hi everybody, as promised, I'm going to do a debugging lesson now to help you take the next step for you in becoming a better debugger. So I've summarized a couple of things here that I think exemplify how beginners debug versus how more experienced people debug. So a complete novice will stare at the code and hope they see the problem. Or they might try and make random changes to for the things that they think are broken and then test to see if that fixes it. That's what I call bugging by guess and check. Those are both going to be very slow and frustrating. You guys are, or most of you I think, are at the beginner level where you use print statements to display the values inside variables so that you can see as it's running. Do those variables hold the numbers you're expecting to see? And that's actually a pretty powerful method. But as you've experienced recently, that's sometimes not enough. So I'm hoping to take you through some things that more experienced debuggers do to make your experience a little more enjoyable. So what we're going to do is we're going to write code that's more interactive, that will let us see interactively whether the output of the method is what it should be. And that's the first thing. And then the second thing is we're going to systematically test each of the methods, starting with the one that's kind of the most basic that the other methods build on. So let's actually do this together. I would like you guys to literally do what I'm about to do. So this is the repository that I emailed to you. This is the debugging repository. Let's do the first step together where we include the assets folder. So you'll right-click, go to Properties, Java Build Path, Libraries tab. My assets folder is already here, but yours will look like this. So then you click Add Class folder. And then scroll down to whatever it is that you named your repository. Mine's called OMR Debugging. And so then there's the assets folder. If that's worked, you should be able to run the visual tester. And there it is. Okay, but let's not start there. Let's start by just looking at the optical mark reader class really quickly. So the group who did this did a really great job with their variable names. So it's pretty easy to tell what's happening. They have three major methods. They've got determined bubble, which is that method that loops over 5 boxes and determines which of the boxes is the darkest, and whichever one is darkest, it returns like they've bubbled A, B, C, D, or E. Way down at the bottom, they have the getPixelAt method, and this is the one we wrote together. It gets a pixel out of the image. And then getSumValue is a method that will count the number of black pixels inside a rectangle whose upper left-hand corner is RC and whose width and height are width and height. Except theirs is a little bit different if you look. They're counting pixel values. Or I guess they're not really counting them. They're getting the actual raw pixel values and adding them into a sum, and then at the end they divide it by how many there were. So this method is actually returning kind of the average color value over that square rectangle. On yours, these 3 lines are going to be uncommented. I actually commented them on mine. And you can see this is evidence of this group trying to debug their problems. They're trying to display what's the sum, what's the counter. This might work, but the problem is it's really hard to tell because getSumValue runs on so many different places. What you really want to do is be absolutely sure where you're running it, and then is the output reasonable. So let's write an interactive visualization for testing if each of these methods really gives the right output. So here we are in Visual Tester. Why don't you scroll down to the draw method. Inside the draw method, it looks like they're already trying to do this. So here they have a getPixelAt, and they're displaying it to the screen. So go ahead and run. And you see this output where it says color 255. 255 is white, and my cursor is on white pixels, so that's reasonable. And then if I go down here, okay, so it should turn black as I move over the black pixel, but it doesn't seem to be. Oh, except then it turns black here when I'm over a white pixel. So right away, that's an indication that getPixelAt isn't giving me reasonable values. Okay, but wait a second. I'm noticing that this getPixelAt method doesn't seem to be connected to the optical mark reader at all. So let's go to this method. Why don't you hold the control key and click on getPixelAt. And if you notice, it jumps you to the top of Visual Tester. So this group has written their own getPixelAt method inside Visual Tester. This was a really good idea, but this isn't going to help with debugging because we want to know whether or not the getPixelAt method that's being used inside Optical Mark Reader is working. We want to know, is this one working? So it doesn't help a whole lot to write a separate one and then see if the separate one is working, because that just introduces a different thing that might be going wrong. Like, how do we know that it's not this one that's going wrong? So instead what we're going to do is go back to Optical Mark Reader, and let's make this method static. So if this method is static, that means we can run it straight from Visual Tester. We can say Optical Mark Reader dot getPixelAt. So let's run it again, and this time we're going to be running the actual getPixelAt. Okay, so it still looks kind of intermittent, doesn't it? Okay, so there maybe really is a problem going on here. So So the absolute first thing that you want to check whenever a method doesn't work is check to make sure the inputs match and check to make sure the output matches. So I'm passing in mouse X, mouse Y. Let's go to the method. It's expecting a row and a column. So I think, do those things match? Mouse X. Okay, so right away I know that doesn't match because mouse X is like an X coordinate, but a row is like a Y coordinate. So let's reverse these. Mouse Y is like the row, and mouse X is like the column. Okay, now let's run it again. So now 255 is white. Great, and only when my cursor hits the black pixel does it turn to black. And here it looks like it's mostly black with a couple of white pixels. That looks correct. Okay, so this was like a kind of a spot check, but at least now this looks more reasonable. It looks like that method's working. So that's the idea. There's two more methods that we want to check interactively in this way. So I'm going to comment this out. What we want to do next is we want to run the next method up that uses getPixelAt. So let's go back to Optical Mark Reader. It's getSumValue. So let's do the same thing. Let's make getSumValue static so that we can run it from somewhere else. Here I am in Visual Tester. GetSumValue returns an int, I think. So I'm going to call this average color. And now I'm going to run statically Optical Mark Reader dot getSumValue. And I want it to have a rectangle that's right where my mouse is. So the row will be mouse Y, the column will be mouse X. And let's do a box that's 37 pixels by 37 pixels. And then image is going to be, what's their image called? It's called current image. Okay, here we go. And so then I can use the text command, and I can display color, and then average color. And I'm going to display it located just a little bit past their mouse. Mouse X plus 20, mouse Y plus 20. Or maybe I'll do minus 30 so it displays above. So I can run this now. And it's giving me a number. It's also going really slowly, and you might wonder why, and the answer is because here in the console it's displaying stuff. Displaying in the console slows everything down. So let's go back to getSumValue and remove the print statements. Let's try it again. Okay, so it's giving me a color value here, but what makes this harder to check is I can't actually see the box that it's looping all the pixels over. So what might be nice is to add a box. Let me show you how to do this, because you're going to need to do this on your own in just a second. The rect command will draw a rectangle, and I want the rectangle to be located at my mouse X, mouse Y, so that's the coordinates of the upper left-hand corner of the rectangle, and then you give it the width and the height of the rectangle. And I don't want the rectangle to be filled, so you use the no fill commands to make sure that it's not being filled in. So now when I run it, it's drawing a rectangle over the same pixels that the method is looping over. So here it's saying that the average pixel value is 254, 255, so that's all pretty close to white, so that's what I'd expect. Here, if I put it over a bunch of black pixels, it's saying 244. And that's versus 240. So now this also looks wrong. Because I'm thinking, look, inside the square is all white pixels, but it says the average color value is 246. But I'm expecting 255, because that's what you'd get with all white pixels. So it really doesn't seem to be properly finding the average for what's inside the box here. So I'm just about to cut you loose and have you continue debugging on your own. But if you remember last time, we needed to double check the inputs. So does mouse Y make sense as the first input? Does mouse X make sense as the second input? So you'll double check that. Then, if that doesn't work, imagine what are the I values that it's really going to loop over, and what are the J values? And then it's going to get pixel at R plus I, C plus J. So really imagine, is that getting the pixels that you want to be getting? Because my guess is probably not. So you can debug that. Then once that one's debugged, the last step is use determine bubble. So make this one static. Go back to visual tester and run determine bubble from the visual tester. Instead of drawing one rectangle, why don't you draw 5 adjacent rectangles so that you can really see what are the 5 bubbles and kind of line them up. That will be your whole homework. I hope that this is going to be a more enjoyable debugging experience. Good luck!